Have you ever wondered how an engine can become extremely hot without simply overheating every time you drive? Inside a running engine, combustion produces a large amount of heat. That heat has to be controlled and removed continuously. But where does the heat go? And how does a radiator, sitting at the front of the vehicle, help keep the engine within its proper operating temperature? To understand this, we need to follow the coolant from the engine to the radiator and back again. A radiator is an important part of an engine's cooling system. Its main job is to help remove heat from the engine coolant and transfer that heat to the surrounding air. When an engine runs, fuel burns inside the combustion chambers. The combustion process produces heat, and some of that heat is transferred to the engine's metal components. If too much heat remains in the engine, its temperature can continue rising. The cooling system is designed to control this heat. One of the main components of this system is the coolant. Coolant is a liquid that can absorb heat from the engine and carry that heat away. The coolant does not simply remain inside the radiator. It continuously moves through passages in the engine and through the cooling system. To understand the radiator, we first need to follow where the coolant begins. When the engine is operating, coolant flows through passages around areas that become hot. These passages are built into the engine block and cylinder head. The coolant moves through these passages. It absorbs heat from the surrounding engine metal. The coolant becomes hotter as it travels through the engine. The heated coolant then needs somewhere to release that heat. This is where the radiator becomes important. A water pump circulates the coolant through the cooling system. The pump pushes the heated coolant away from the engine and toward the radiator. The hot coolant enters the radiator through an inlet. Inside the radiator are many narrow tubes. The coolant flows through these tubes while heat moves from the coolant into the surrounding metal. Attached to the tubes are many thin metal fins. These fins greatly increase the surface area available for transferring heat to the air. This is an important part of the radiator's design. Instead of having only the surface of the tubes exposed to the air, the fins provide much more metal surface through which heat can move. As the hot coolant passes through the radiator tubes, heat moves from the coolant into the tubes and fins. The surrounding air then carries that heat away from the radiator. This is the basic principle behind radiator cooling. The radiator does not create cold. Instead, it provides a large surface area that allows heat to move from the hot coolant into the surrounding air. Airflow is therefore very important. When the vehicle is moving, air enters through the front of the vehicle and passes through the radiator. This moving air removes heat from the radiator fins. The faster and more effectively air moves through the radiator, the more heat can be transferred under suitable operating conditions. But the radiator cannot always depend on the vehicle moving. A vehicle can be stationary while the engine is running. That is why many vehicles use an electric cooling fan. The cooling fan moves air through the radiator when additional airflow is needed. The fan can operate automatically according to the engine's temperature and the vehicle's cooling requirements. Now let's follow the coolant through the complete process. The engine is running and producing heat. Coolant absorbs some of that heat as it moves through the engine's internal passages. The heated coolant travels toward the radiator. The hot coolant enters the radiator. Inside the radiator, the coolant moves through narrow tubes. Heat transfers from the coolant to the radiator tubes. The heat then spreads into the radiator fins. Air passes across the fins. The air absorbs heat from the fins and carries it away from the radiator. As the coolant loses heat, its temperature decreases. The cooled coolant leaves the radiator. The water pump then circulates the coolant back toward the engine. The process repeats continuously while the cooling system is operating. This continuous circulation is what allows the system to keep removing heat from the engine. But the cooling system also needs to control when coolant flows through the radiator. This is where the thermostat becomes important. The thermostat is a temperature-controlled valve located in the cooling system. When the engine is cold, the thermostat restricts coolant flow through the radiator. This allows the engine to warm up more quickly. As the engine reaches its operating temperature, the thermostat opens progressively. This allows more coolant to flow toward the radiator. The radiator can then remove heat from the coolant. The thermostat therefore helps regulate coolant temperature rather than simply allowing maximum cooling all the time. This is important because an engine is not designed to operate at any random temperature. It needs to operate within a suitable temperature range. If the engine remains too cold, combustion efficiency and other engine functions can be affected. If the engine becomes excessively hot, components can be damaged. The cooling system therefore works to control the engine's temperature. The radiator is one part of that larger system. The cooling system operates under pressure in many vehicles. Increasing the pressure raises the boiling point of the coolant, helping the system operate effectively at elevated temperatures. The pressure control system also allows coolant to move between the radiator and expansion reservoir as temperature and pressure change. As coolant becomes hotter, it expands. The cooling system must have a way to accommodate this expansion. When the coolant cools down, its volume decreases again. The expansion reservoir provides space for these changes in coolant volume. The radiator itself also has an important physical design. Its tubes provide pathways for coolant. Its fins provide additional surface area. The radiator's overall structure allows coolant and air to remain close enough for efficient heat transfer without mixing together. The coolant stays inside its passages while air moves around the outside of the tubes and fins. Heat moves between them through the radiator material. The two fluids therefore perform different jobs. The coolant carries heat away from the engine. The air carries heat away from the radiator. This creates a continuous heat transfer process. The radiator also has an inlet and an outlet. Hot coolant enters through the inlet. After passing through the radiator and releasing heat, cooler coolant leaves through the outlet. The exact location and design of these connections depend on the vehicle and radiator design. Some radiators also include separate sections for other cooling functions, depending on the vehicle. For example, some vehicles use radiator assemblies that also help cool transmission fluid. The purpose is still based on the same general principle. Heat is transferred from a fluid into the radiator and then into the surrounding air. Now consider what happens when airflow is reduced. If the vehicle is moving slowly or standing still, less natural air may pass through the radiator. The cooling fan can compensate by forcing air through the radiator. If airflow is still insufficient, coolant temperature can rise. The condition of the radiator also matters. Dirt, debris, insects, or other material covering the fins can reduce airflow through the radiator. Damaged or bent fins can also reduce the effective airflow area. The cooling system therefore depends on more than just the radiator itself. The water pump, thermostat, fan, coolant passages, hoses, pressure control system, and radiator all work together. A problem in one part can affect the entire cooling process. For example, if coolant cannot circulate properly, heat may not be carried away from the engine effectively.
If the thermostat does not operate correctly, coolant flow may not be properly controlled. If the fan does not provide sufficient airflow when needed, radiator cooling can be reduced. If the radiator cannot transfer heat efficiently, the coolant may remain too hot. This shows why engine cooling is a complete system rather than the work of one component. Let's now summarize the entire process from beginning to end. The engine produces heat during operation. Coolant absorbs heat from the engine. The water pump circulates the heated coolant. The hot coolant enters the radiator. The coolant flows through narrow radiator tubes. Heat moves from the coolant into the tubes. The heat spreads through the radiator fins. Air moves across the fins. The air carries the heat away. The coolant becomes cooler. The cooled coolant leaves the radiator. The water pump sends it back toward the engine. The thermostat helps control the flow according to temperature. The cycle continues as long as the engine and cooling system are operating. That is how a radiator works.